Hello everyone, welcome to VCD Academy. This is Anil Kumar, Faculty of Digital Electronics. Now I would like to explain one more gate called XOR gate. Sir, up to now we have seen what are the three types of basic gates, which are NOT gate, AND gate and OR gate, and also we have seen what are the universal gates, we can say NAND gate and NOR gate, and all its properties we have seen. Now let us try to understand XOR gate, and now what is the associative law for XOR gate, and what is the commutative law, and also what are the unused inputs, and we can say what is the properties or characteristics of XOR gate. Let us try to understand. Sir, the moment whenever we are studying about any logic gate, I told you in the previous lecture even, we need to see the few points, which are, the first thing is what is its logic circuit. What is its logic circuit? What is the truth table? What is the truth table? And third one is number of inputs and outputs. Fourth one is logical expression. And fifth one is what is the control input 0, and what is the control input 1, and what is the commutative law, and what is the associative law. Finally, we just need to see some properties of XOR gate. Let us try to understand these 9 points for XOR gate. Sir, let me start here. We know that the logic circuit here, first one, logic circuit of XOR gate is this. Here we have this is A input and B. Here Y equal to A XOR B. This is what logical circuit. And coming to truth table, sir, here truth table, which we can say second one, truth table. Here for truth table we have two inputs, which are A and B. Now here Y equal to A XOR B, I can write this as Y equal to A bar B plus A into B bar. I can also write this expression A XOR B like this. So based upon this interpretation, we can write like A, B are the inputs, and now here A bar I will take, and also I can take B bar, and now let me multiply A bar into B, and now I will multiply A into B bar, and finally I want to add A bar B plus A into B bar. So this will be our truth table. Sir, let me consider here 4 inputs, which are, because we have 2 inputs A and B, so we will be getting 4 input combinations, which are, I can say the first one is 0 0 0 1 1 0 and finally 1 1. Now let me calculate all the possibilities for these 4 inputs. The first one is, here we have A bar, and second one is B bar, and third one is A bar B, and fourth one is A into B bar. Sir, here we have A bar, which means we just need to complement what are the inputs available at A. So now let me take here A, first input is 0, so I can complement it, so it will be automatically 1. Here also second input 0, it will be complemented to 1, because this is what A bar. Here 1, it will become 0, here 1, it will become 0. And after that we can say B bar. Here B bar, this is 0, we can say 1. here 1 it will become 0, here 0 1, and now 1 it will become 0. So this is what complementation of A and B. After completion of complementing, let me try to multiply A bar into B. Here A bar into B, which means I just need to multiply these two, B into A bar. So 0 into 1 we can say 0, 1 into 1 we can say 1, 0 into 0 0, 1 into 0 we can say 0. Sir, the next thing that I need to multiply is A into B bar, which means A into B bar I need to multiply. Here first input is 0, here 1 I can say 0, and now here 0 and here 0 we can say 0, and here 1, and third input is here also 1, 1 into 1 output is 1, 1 into 0 here 0. Now the final thing to get the output of XOR gate is here A bar B plus A into B bar, which means we have A bar B and then A into B bar. So we just need to add these two outputs so that we will get final output. Here addition of these two values, here 0 0 we can say 0, 1 plus 0 we can say 1, 0 plus 1 here 1, and now 0 plus 0 0. So this is what the truth table of XOR gate, and based upon this truth table we just need to understand few things here. The moment when we are taking here A equal to 0, B equal to 0, we are getting output as 0. And now when A equal to 1, B equal to 1, we are getting output as 0, which means whenever the inputs A equal to B, either for 0 or for 1 we can say, whenever the inputs A equal to B, we are getting output as 0. Whenever the inputs here, see sir, when A equal to 0, B equal to 1, the output is 1, and now when A equal to 1, B equal to 0, output is 1, which means whenever A not equal to B, then the output is 1. Sir, this is the understanding from the truth table. Based upon this understanding, we can analyze what are the control inputs and what is the associative commutative law. Let us try to understand. Sir, here third point, after completion of truth table, we can take the third point is number of inputs and outputs. For this particular XOR gate, we have two inputs which are A and B. Here number of inputs we can say 2, and now finally number of outputs we can say 1, which is Y equal to A XOR B. And coming to fourth one, that is called logical expression. Here logical expression, so logical expression, let us try to understand. Here Y equal to A XOR B, this is a basic logical expression. If I can expand it, I can write it as A bar into B plus B into A bar. This is what expanded expression. I can say this is SOP, sum of products output I can say. And now if somebody can ask me in competitive exams also, sometimes the question is asking like this. Here Y equal to A plus B into A bar plus B bar. So this is what POS form. We can say product of sum, POS, or we can say this is POS, product of sum. Let me explain what is SOP and what is POS, product of sum, SOP, sum of products. We are going to learn in the next classes. Now, up to now, let us try to understand. If you want to represent our logical expression of XOR gate in SOP, sum of products form, we can take A bar B plus B into A bar. If you want to represent our logical expression of XOR gate in the form of product POS, we can say product of sum. We just need to represent as Y equal to A plus B into A bar plus B bar. Sir, after completion of fourth point, let us try to understand the fifth point, that is called control input, 0 and then 1 condition. Sir, let me take this fifth point here. control input 0. What will happen when we keep one of the inputs of XOR gate is keep on 0? Let us try to analyze. Sir, this is XOR gate. This is XOR gate, and now this is input A, and now this is input B. Here y equal to A XOR B. Sir, let us try to understand the things. Suppose if I can keep on apply here B equal to 0, and if I want to change the inputs A equal to, here the first one is 1, 0, and then X. Let me take one a square wave. So if I can keep on changing these input values, what will happen, sir? Sir, I know that the truth table of XOR gate, let me draw here. Sir, A, B, and now y equal to, here y equal to A XOR B. Here 0, 0, 0, 1, 1, 0, and 1, 1. I know that if A equal to B, automatically output is 0. And then A not equal to B, I can say output is 1. I told you. So that here A0, B0, which means output is 0. And then here A1, B1, output is 0. We can say here A0, B1, which means not equal. So output will be 1. And now here 1 into 1. Here A and then B is 0, so not equal. So I can get output as 1. This is what simplified truth table. Based upon this simplified truth table, let us try to understand the control input 0 condition. So here B equal to 0, which means the first condition I can take A equal to 1 and then B equal to 0. We can say both the inputs are not equal. So I can say directly here output is, we can say 1 we get. Of course, let us try to check from the truth table. Here A equal to 1 and then B equal to 0. Output is 0, or we can say output is 1. And now the next condition, here A equal to 0 and then let me apply B equal to 0 even. Here sir, the both inputs are zeros, which means A0 and then B0, output is, we can say 0. Here output is 0. And now here A equal to X I can take and then B equal to 0. I told you sir, here from the truth table we can understand if both the inputs are equal, then only output is 0. Both inputs are equal, either both inputs are zeros or both inputs are ones, whatever it is, but the both inputs must be equal, then only the output is 0. Otherwise, if both inputs are not equal, then we can get output as 1. Here sir, A equal to X and then B is 0, which means both are not equal, we can say. So we can get output as 1. And now, or we can say 1 we can get, or I can also write here instead of 1 I can write X, because we are applying one of the inputs as X. And now the fourth input, here A equal to square wave and B equal to 0 here. Again both inputs are not equal. So based upon the truth table, when A and B are not equal, we can get output as 1. So here we can get output as square wave. So this is what the control input, which means after analyzing these four input combinations, here whatever we are applying as input, the same we are getting as output, which means can I say that the control input XOR gate for 0, the circuit is acting as a buffer? Yes sir. Yes sir. Here the circuit is acting as a buffer. We can also tell that here the circuit is acting as memory element. So these are the things. And now let me take the next example sir to understand better here. Next example, the fifth or sixth one, control input 0 condition. Control input, here 1 condition, sorry. Here the sixth one, control input is 1 condition. Now let me take XOR gate. Here A equal to, let me take 1, 0, X and then any square wave to understand. Here B is 1, B equal to 1. Here Y equal to A XOR B. We know that the 4 conditions. Now let me try to analyze. When A equal to 1 and B equal to 1, what will happen? here both the inputs are equal, so I can get output is 0 immediately. Blindly I can say when both inputs are zeros, then output is 0. And now when A equal to 0, B equal to 1, here sir both inputs are not equal, so I can say that output is 1. Here both inputs are not equal, which means A equal to 0, B equal to 1, you can say output is 1. And now let me take the third condition, A equal to X and then B equal to 1. Here also both inputs are not equal, so here B equal to 1 and then A equal to something else other than 0, so other than 1. So whatever the input may be for A, if it is not at all 1, then we can say input is not equal to B, so output must be not equal condition. So we can say when A not equal to B, output is automatically 1. So can I say that sir here output is X, so can I say here output is X bar, and then here A equal to, the fourth condition is square wave, and then B equal to 1. Here also both inputs are not equal. Sir, we just need to understand one thing. The moment when we apply here A equal to 0 and then A equal to 1 and then 0. First condition when we apply A equal to 1 and then when we apply A equal to 0. What happens sir for these two conditions? Here when we apply A equal to A equal to 1, I get output as 0. When I apply A equal to 0, I get output as 1. Automatically, based upon these two conditions, I can understand sir the circuit is acting as an inverting operation. So for this operation will continue even for we apply A equal to X or square wave or something else. So the moment when I take A equal to X, when B equal to 1, of course these two are not equal, then the output is producing as X bar, because the circuit is proved that circuit is acting as a inverter. And now here A equal to square wave, I can say that here the square wave is also inverted. So this is what output. And now let me take, these are the two conditions of control input 0 and then control input 1. Here for control input 0, the circuit is acting as a buffer or memory element, and then control input 1, the circuit is acting as, we can say, inverter. And now let me take the sixth or seventh condition, commutative law, whether the circuit is following commutative law or not. Sir, here seventh condition, commutative law. We know that the commutative law means when we interchange the inputs. Here this is A, B, Y equal to AX or B. If I can interchange the values, here A bar B plus A into B bar. If I want to interchange the values, which means if I can interchange the values or inputs, we can say here B A XOR gate, Y equal to B XOR A, which means Y equal to B bar A plus A bar into B. If I can write this expression, even the both inputs are interchanged, even then the output is same. Here the output is same. So I can say that commutative law is satisfied. If you want to verify, we can take one truth table, and based upon the truth table output, we can say that the commutative law is satisfied for this particular, we can say, XOR gate. And so after completion of commutative law, let me take the eighth condition called associative law. Associative law. Here we can say that the XOR gate is not following associative law. Let us try to understand. Here the moment when we add one more input, here this is A and B, and now output is Y1 I can say, and now let me take another input here C. Suppose if it is output Y2, which means here A XOR B here output, and now here Y2 equal to Y1 XOR C I can say. So I can write it as Y2 equal to A XOR B XOR C. This is what the equation. And now if I can interchange the values, which means here let me take B C XOR gate, and now here Y1, and now let me take here A, and then I want to connect with another XOR gate. This is Y2. Here Y1 equal to B XOR C, and then here Y2 equal to, we can say Y2 equal to Y1 XOR A, and finally I can write Y2 equal to B XOR C XOR and then A. So this is what, sir, based upon these two conditions we can say that XOR gate is not at all following associative law, because when we draw a truth table for these two conditions, for first condition case 1 and then case 2, here these two cases are not at all equal for their output, so we can say that XOR gate is not at all following associative law. The leftover part here is properties of XOR gate. Sir, we have few properties of 9th point, properties of XOR gate. So let us try to understand few properties here. The first property is for XOR gate, suppose if we can connect even number of gates, which means let me take here A plus A XOR A, which means we can get output as 0. And now here A XOR A, we can say output as A, which means here when we are connecting the same inputs in the even number, output may be 0. And now when we connect inputs for a same digit or same input in the odd number, we can get output as A. And then third condition is, suppose if A XOR A bar, we can say output is 1. And then fourth point is here A XOR 1, which is equal to A bar. These are the four conditions. And then fifth one is, suppose if A XOR B XOR equal to A XOR B equal to C, then A XOR C equal to B, and now B XOR C equal to A we can say. And now here the next thing that we need to understand, sir, what are the how many number of min terms and max terms. Suppose if we can say sixth point, if n number of XOR gates are connected, then what is the how many number of min terms and max terms? Min terms to calculate min and max terms, we have equation called 2 power n minus 1, or also we can write as 2 power n by 2. So here this is what equation to calculate the min terms and max terms. What is min term, what is max term, we are going to see. Now as of now let us try to understand this equation. If n number of XOR gates are connected, and then to calculate out of those connected XOR gates, to calculate the number of min terms and max terms, we have equation called 2 power n minus 1. So based upon this equation, let us try to understand what is n here and what is 2 power n by 2. and how to calculate min terms and max terms when we are getting 2 power n equal to 1 or 2 or 3 or 4, which means let us try to understand. We know that, sir, the equation called 2 power n. Here, sir, here in the basics class itself we have learned about 2 power n. What is n here, sir? N equal to number of inputs here. Here n equal to number of inputs. 2 power n is the equation to calculate number of input combinations. Sir, here suppose here n equal to 1, which means only one input is available. To calculate the number of input combinations, we took equation 2 power n, which means 2 power n equal to here 2 power 1, which means 2 input combinations. I told you in the earlier classes 2 combinations are 0 and 1. Here these are the 2 input combinations. Out of these 2 input combinations, here we have one min term and another is max term. Here we can say another is max term. So that is what the thing that I want to tell here. Here 2 power n by 2, which means it is divided. So based upon the out of available input combinations, 50% are min term and then 50% are max term. Sir, let us try to explain more. Sir, here when n equal to 2, which means 2 square, here 2 square, 2 power n, of course, here 4 combinations. And now n equal to 3, which means 2 power n equal to 2 cube, we can say we have 8 combinations. N equal to 4, we can say 2 power n, 2 power 4, we can say here 16 combinations. N equal to 5, here 2 power n, we can say 2 power 5. Of course, we have 32 combinations. These are the input available combinations. Now, suppose 2 power n by 2, which means here if I can add here 2 power n by 2. These are the input combinations. And now for the given input, suppose if I can add 2 power n by 2, 2 power n by 2, here 2 power n by 2, 2 power n by 2, 2 power n by 2, here by 2, by 2, by 2, by 2, which means we can say the resultant one is min term and max term. Here 1 and then 2, here 4, here 8 and then here 16. So that for input 1, we can say input n equal to 1, for input n equal to 2, we have here min term and then here as max term. Sir, here one min term and one max term. Here for n equal to 2, here 2 min terms and here 2 max terms. For n equal to 3, here we have 4 min terms and then 4 max terms. Here n equal to 4, we have 8 min terms and then 8 max terms. Here for n equal to 5, we have 16 min terms and then 16 max terms. This is the thing that we need to remember for competitive exam point of view. Sometimes the question is asking based upon the equation 2 power n by 2. So these are the properties of XOR gates. We just need to remember to calculate more problems in the next further classes. We just need to remember these 5 equations, or we can say 6 equations. This is what XOR gate. Now let us try to understand XNOR gate. This is also similar gate as like XOR gate. We have few modifications. Let us try to understand. Thanks for watching. Please do subscribe.